My dear student, I am Pradeep Srivastav. I want to teach about concept of electric field. It is a space property. Therefore, the electric field due to a given charge can be defined as the space around it in which electrostatic force of attraction or repulsion due to this charge can be experienced by any other charge, where R the space around a charge in which its electrical influence can be experienced by other charge is known as a electric field. Now, intensity of electric field, capital E. Intensity of electric field at any particular point of the electric field is equal to the force experienced by unit positive test charge placed at that point. It is a vector quantity and it is represented by capital E. If F is the force experienced by the positive test charge plus Q naught placed at a point in an electric field, then intensity of electric field at that point is given by vector E is equal to vector F upon Q naught. If Q naught is equal to 1 coulomb, then vector E is equal to vector F. If F is equal to 1 upon 4 pi epsilon naught K Q into Q naught upon R square, so intensity of electric field at a point will be given by E is equal to F upon Q naught is equal to 1 upon 4 pi epsilon naught K Q into Q naught upon R square whole upon Q naught, where R E is equal to 1 upon 4 pi epsilon naught K Q upon R square. For air or vacuum, K is equal to 1. Therefore, E is equal to 1 upon 4 pi epsilon naught Q upon R square. Discussion first. From equations second and third, it is obvious that E is directly proportional to 1 upon R square. So, graph between E and R will be shown in figure. Second, in the vector form, vector E is equal to 1 upon 4 pi epsilon naught Q upon R square into unit vector R, where R is the unit vector directed from the source charge plus Q towards the test charge plus Q naught. Now we discuss about electric dipole, a system containing two equal and opposite charges separated by a finite distance is called an electric dipole. Dipole moment of electric dipole having charge plus Q and minus Q at separation 2L is vector P is equal to Q dot 2L. It is a vector quantity directed from minus Q to plus Q. Now find an expression for the electric field strength at a distance point situated first on the axis and second along the equatorial line of an electric dipole. Consider an electric dipole AB. The charges minus Q and plus Q of dipole are situated at A and B respectively. The separation between the charges is 2L. Electric dipole moment P is equal to Q dot 2L. The direction of dipole moment from minus Q to plus Q at axial or end on position. Consider a point P on the axis of dipole at a distance r from midpoint O of electric dipole. The distance of point P of charge plus Q is Bp is equal to r minus L, and distance of point P from charge minus Q is Ap is equal to r plus L. Let E1 and E2 be electric field strength at point P due to charge plus Q and minus Q respectively. We know that the direction of electric field due to a point charge is away from opposite charges and toward the negative charges. Therefore, E1 is equal to 1 upon 4 pi epsilon naught Q upon R minus L whole square from B to P, and E2 is equal to 1 upon 4 pi epsilon naught Q upon R plus L whole square from P to A. Clearly, the directions of electric field strength E1 and E2 are along the same line but opposite to each other, and E1 is greater than E2 because positive charge is nearer. The resultant electric field due to an electric dipole has magnitude equal to difference of E1 and E2 of direction from B to P. E is equal to E1 minus E2 is equal to 1 upon 4 pi epsilon naught Q upon R minus L whole square minus 1 upon 4 pi epsilon naught Q upon R plus L whole square is equal to Q upon 4 pi epsilon naught in bracket 1 upon R minus L whole square minus 1 upon R plus L whole square is equal to Q upon 4 pi epsilon naught in bracket R plus L whole square minus R minus L whole square upon R minus L whole square R square minus L square का whole square is equal to Q upon 4 pi epsilon naught 4RL upon R square minus L square whole square 1 upon 4 pi epsilon naught 2 Q into 2L into R upon R square minus L square का whole square, but Q into 2L is equal to P. Therefore, E is equal to 1 upon 4 pi epsilon naught 2PR upon R square minus L square whole square. If the dipole is infinitely small and point P far away from the dipole, then R is smaller and smaller than L. Therefore, equation may be expressed as E is equal to 1 upon 4 pi epsilon naught 2PR upon R power 4 or E is equal to 1 upon 4 pi epsilon naught 2P upon R cube. This is the expression for electric field strength at axial position due to a short electric dipole.